Hello, this video is going to show you how you can do statistical process control analysis um, with attribute data. So if you recall from our previous couple of videos, we have been working on this example where we have a variable. A variable refers to the paint thickness level on certain cars, right? So that thickness level can be in fractional form. So therefore, theoretically, it can take up infinitely many different observations, right? And it cannot be countable. Um, Remember, one of the differences between an attribute and variable, attributes, we try to collect information that can be countable, right? It can be either like number of defective units versus non-defective units, number of successes versus failures, good versus bad, those kind of like binary relationships that we can attribute to a certain attribute or feature. So in this data set example, we do have different subgroups. So we do have actually shipments here, and those are referred to as subgroups or samples. We do have 25 of them, and each shipment, we don't know what the size of it, but we do have the certain sample that we select out of that shipment. So we look at 250 peaches, we control them, and we note how many of them has some bruises on them, right? So in the first shipment, we selected 250 peaches out of that shipment, and we observed that 47 of them are defective. And second one, 42, third one, 55, so on and so forth. So you will see that I always select 250. I don't have to, this number can change, but let's assume that for this example, it is fixed. I look at 250 peaches from every shipment, and I note down how many of them has bruises on, and if they do, I mark them and then note them here. Okay, so if you have these kind of data, again, defective, non-defective, good, bad, failure, success, then you cannot really use the variable control charts. You just need to go to stat and then control charts, locate attribute charts. There are 4 different options. So Pchart, in Pchart, U chart, and C chart. But then P and U charts are almost like special conditions of P chart and C chart. Let's assume that you are interested in looking at the proportions of the bruised peaches across samples, right? So that's, in this case, it will be 47 divided by 250 would give you a proportion, right? Let's assume that you would like to portray that chart and then see whether your proportions are under statistical process control. In that case, you need to know, number of defectives or number of successes, and you need to know your sample size, right? So let's try to do that first. Again, go to stats, control charts, attribute charts, and that's called Pchart. Let's click on Pchart. In the Pchart, I would like to use the bruised column, which is going to keep track of my defective units. And my subgroup sizes, I can either enter 250 here, but instead I'm going to enter the column name where I keep the subgroup size or sample size information in, and that is the second column. You can select a bunch of different charting options. You can play with the labels, the type of the chart. You can do multiple graphing here. Not going to do that. You can look at Pchart options. You do have certain limits that you can play with, but I'm not going to touch anything other than clicking OK. So in this chart, I do have my proportion. So what Minitab does here, again, from the data, it calculates my upper control limit and lower control limit. and it captures my center line. It's literally the average of the bruises across all subgroups, right? And these blue dots, for example, the first blue dot is 0.188. It corresponds to 47 divided by 250. Let's calculate that. 250 gives you 0.188, right? And then for the second blue dot, you see that it is 0.168. Again, it corresponds to 42 divided by 250. Okay, 0.168. All right, so we got the confirmation. Again, what you see here is they look under statistical process control. Nothing to worry about at this point. No blue dots are exceeding above and below the control limit. So there is no point of stopping this operation. We just keep continue. Again, process capability is a different thing. So this is statistical process control. Okay, so what happens here is you might have different sample sizes. So one day you just collected 100 peaches. The other day you can collect like 350. And the other day you can collect 500. And how do you handle that operation? Well, you're not going to do something different. You can still continue what you're doing with the Pchart. As a matter of fact, I'm going to change this to 500. And I'll hit enter. You see, Minitab is warning me now. It says that the results do not use current data. If you would like to use the current data, update these results or create new results using the current data. Well, I'll just go ahead and click update my results. What is going on here? So I updated this to 500, and then I assume that the number of peaches did not change. It did change my upper control and lower control limit. And all of a sudden, it looks like I do have way less bruised number of peaches. I should not be really concerned here because I do have a less number of defective peaches, but it creates a lot of variation in my data. Let's try to increase this to, let's say, 110. All right. Again, Minitab is going to give me a warning saying that you have to update these results and change. You see that it's much more much better representation of what's going on. And then again, it updated my lower control limit and upper control limit. So we use Pchart when we are interested in trying to capture statistical process control in our operations with various different subgroup sizes, like in this case. And your subgroup size or sample size is not fixed. So that should do the trick. Let me change it back to 250, and I guess this was 51. And let's update this. All right, so this is what I had originally. What if my sample size doesn't really matter? Meaning that, for example, you are working on a one large operation. Let's say it's a huge airplane, and you're interested in calculating the number of defectives on that airplane. It can be like, regarding the seats, regarding the carpets or windows or the pressure on the air, blah, 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 blah. But it is on the same airplane, right? One big airplane. Several times you do that and your sample size is not changing, you can assume that it is one. If you have those kind of operations, then you can use definitely Pchart. Again, go to stat, control charts. Here it should be attribute charts and Pchart at the very bottom. And I will be looking at my bruised peaches here. As you can see, it doesn't ask me my subgroup size. I hit OK. It is literally giving me this time. These blue points are actually my number of bruised or defective peaches. As you can see, sample count is 47. This is the 47. It picked up this number. Excuse me. And the Minitab calculates the upper control limit and lower control limit directly from the data. So yes, so if you are interested in the expected number of, or monitoring the number of defective units in your process, rather than the proportions of the defectives, then you can switch to Pchart anytime. You can use Pchart as well. Pchart is just a minor modified version of the Pchart. Well, let me show that to you as well. Control charts, attribute charts, and Pchart. This time again, nothing is going to change. I'm interested in number of defective units. It is asking me the sample or subgroup size. I keep them here, and I hit OK. And again, I do have 47, 42. Those are the bruised breaches here. What changed between the Pchart and Pchart are those estimation of those upper control limit and lower control limit. When should I use Pchart versus Pchart? Pchart can be used if you have different sample size and you still would like to take a look at the expected number of defectives or the number of defectives in your processes rather than the proportions. If you use Pchart when your sample size doesn't matter, it is the same or it is just one big operation, and you switch to Pchart when your sample size or subgroup size keeps changing. But these two are pretty much telling the same story. Okay, so there's also one other chart called U-chart, but it is not really that much different than the P-chart. It can be used in different occasions for sure, but we're not going to go into that detail. All right, so P-chart and C-chart should be fine, or P-chart and P-chart should be fine in any just to capture most of the statistical process control operations that you deal with. That would conclude our statistical process chart topic.